All right, so today's lesson is on the identity and inverse properties. Excuse me. And I think this will be pretty short because what's most important is being able to identify which property is which. So that way you kind of know how they're used. And I would like you to participate when we get to the examples just to kind of get some interaction. So first, we will start with we're talking about different properties. Well, what is a mathematical property? So when we refer to a mathematical property, we're talking about a rule or something that is a characteristic of something that describes something. So squares have the property that you have four sides and they're all the same length. And that is always true. So that's also why it's a rule. So it's basically something that's always true that describes whatever we're talking about. And so these properties that we're talking about basically describe numbers in a way. So that's kind of like what they're describing is, our number system, how we work with numbers. So these properties are things that are true about our numbers. And the basis of algebra has been built upon by just determining, okay, these are the rules that we're going to follow, and then where do those rules take us? If I do these various things with these rules, what happens? And that's sort of what math is, especially if you get into higher level math. It's a lot of exploration of taking what you know and then trying things to see what it gets you. So we'll start with the identity property. And this is just getting its name basically by it keeps things that are identical to what it was. It's not changing things. So the identity property of addition relates to 0. It's basically saying if you can add, you can add 0 to a number and it doesn't change the value. It's identical to what it was before we added 0. So that's basically the identity property of addition. And we call 0 the additive identity. It's the thing that you add that doesn't change your value. For multiplication, this identity is involving 1 because you can take a number, multiply it by 1, and the number does not change value. It is still equal to whatever it was. And so 1 is called the multiplicative identity. And I know that these seem silly. Of course, I can add 0 to a number and it stays the same. Of course, if I multiply by 1, it doesn't do anything. But these rules are really important and form really important, basically what algebra is all about. And so we've got the inverse property. And so lexico.com is just an online dictionary. And if you look up the word inverse, it says something that is the opposite or reverse of something. Basically, you can think of it as it undoes something. Is it kind of, you did something and then it reverses what you just did. It undoes what it was. So we have the inverse property of addition, where if you take a number and then you add the negative of the number, those add together to 0. This is basically, the negative is also called the opposite, and that comes directly from the definition of inverse. It's the opposite. So if I take 2 and negative 2, you add those together, they cancel out to 0. Or if I take negative 2 plus 2, the order doesn't matter there, but they cancel out and they give us 0. And so basically negative a, whatever the number is in the negative form, is called the additive inverse, or opposite of your original number. But it can also go the other way. So if your number is negative 2, the additive inverse is 2. It's just whatever is the opposite number that will allow it to cancel out. When we look at multiplication, we're looking for these things to cancel out and give us 1 instead of 0. So that is the reciprocal. You take a number and you multiply by the reciprocal of the number, they cancel out, they get you 1. And so examples are, if you have 2, the reciprocal is 1 over 2. Then those will cancel out, you're left with 1. If you have a fraction, the reciprocal is just flipping it, just flipping the top and the bottom. So you're just reversing what's on top, what's on bottom. So again, going back to that definition of the inverse. And so the reciprocal is called the multiplicative inverse because it's the thing you multiply by to cancel out what you have. So we've got these two properties, the identity property and the inverse property. One is about how you keep your number the same. The other one is about how you cancel it out. So why do we have these properties? I've kind of mentioned it before. They form the basis of algebra. But I also mentioned that we use these to solve. So when we start solving equations, we do this by canceling things out, undoing things basically. And so we usually have to use the additive identity, where you are adding these things together to make them add, or not the additive identity, additive inverse. They add together to get to 0. Let me write that down. So we involve the additive inverse, or we're trying to get them to multiply to 1, which is the multiplicative inverse. The other properties, the identity properties, are used. So we use the multiplicative identity a lot when we're trying to get common denominators in order to add things together so that we can then solve. So that's something that's used. The additive identity is used sometimes when you're combining like terms and ends up adding a 0 and then you're just adding 0 to something. So these other ones do get used, but we mostly use the additive inverse and the multiplicative inverse. And so when we use these rules with the properties of equality, that's how we're allowed to solve. Those give us the rules that we're allowed to do what we do when we solve. And that's usually where people get confused. They're like, well, I'm solving. Why are we doing this thing? It's because of these properties. And the other thing that I want to point out is that the inverse and identity properties are related. So the inverse property, like the additive inverse, adds to the additive identity. So we've got this inverse property of addition, which equals 0, and 0 is the additive identity. Likewise, the inverse property of multiplication, the multiplicative inverse, those give you 1, which is the multiplicative identity. So these are related because your goal is to get the identity, and that's what gives you the inverse basically. So this is my only example, is just to identify what properties are being used. So we've got, let me just write down our choices here. We've got the additive identity. It'd help if I spell that right. Which means you're basically adding 0 and it equals itself. The multiplicative identity, which means you're basically multiplying by 1, it equals itself. And then you've got the additive inverse, where they add together to equal 0. And then the multiplicative inverse, I keep missing my letters here, where they multiply together to get you 1. So that is the difference between the 4 properties. So let's just look at the first row basically that we've got. I've got 3 plus 0 equals 0, and then 5 plus negative 5 equals 0. So let's look at 3 plus 0 equals, oh, that's a typo. 3 plus 0 does not equal 0. I was looking at that, I'm like, wait a minute, I typed that wrong. It's supposed to be 3 plus 0 equals 3, because otherwise that doesn't make any sense. So which of the four properties does this seem to go with? We've got the additive identity, multiplicative identity, additive inverse, and multiplicative inverse. So you can type that into the chat, which one you think it is. Additive identity is the first one we got, and that is correct because you were adding 0. So it remains the same. It's identical to what it was before. So that is the additive identity. What about the one on the right? We have 5 plus -5 equals 0. So which property does that? Which one is that one? Additive inverse. That is correct. It is basically canceling out, and it's resulting in 0. So that is the additive inverse property, or the inverse property of addition, which I just use additive inverse because it's just a lot easier. Okay, let's look at the next row. 18 times 1 equals 18. That is the multiplicative inverse. Excellent. We are multiplying by 1, or identity, not inverse. This is the tricky thing, because the words are very close. Inverse and identity, they both start with I. This is the multiplicative identity because it's identical to what it was before. So very careful, because you'll probably do the same thing that I did. You look at what you're talking about. You're like, oh yeah, it's this one, and then you type the wrong word, or write the wrong word, or say the wrong word, because I've done that. So that one is the multiplicative identity because it's identical. All right, now the next one is a tricky one. I just want to see what you go with that. We have 6x minus 6x. Okay, so we've got an idea, multiplicative inverse. I look at this, and the first thing that I notice is subtraction. And something that I'd like to tell people to do is to rewrite subtraction as adding a negative. So see if that helps. Subtraction is adding a negative. So if you rewrite it, we've got addition in there. So it's going to be one of the additive identities, or inverses, the additive properties. It's either going to be the identity or the inverse. And this is the additive inverse because it cancels out. So this is the thing that is really important for once you start solving equations, because we're going to have things with letters, with variables, and our goal is to make them disappear and get 0. And so we use the additive, we want them to get to the additive inverse. We want them to cancel out. And so these properties work even if you don't have only numbers. You still have something, and then you're taking its opposite, and they're canceling out to give you 0. Okay, so now next row, I've got x times 14 over 14 equals x. So again, this is a little tricky one. It kind of gets you thinking. And these are the types of things that you'll see when you solve, which is why I'm putting them in this form, because you'll be using these rules even if they aren't exactly in the form that you're presented the rules, and you're still using them. They just look a little differently. So when you're trying to decide which one it is, first decide, do you have multiplication or addition? And then from there, kind of decide what's going on. Okay, so we've got someone who says multiplicative identity. That is correct. So the multiplicative identity is times 1, and 14 over 14 is 1, because that cancels out. This is just another way of doing times 1. And this is what we use a lot of times when we're actually trying to get a common denominator, and we do solve equations with that you have to get a common denominator. You'll have what's on the right, and you do what's on the left so that you can get a common denominator. So this is the multiplicative inverse going on here. Okay, next one on the right, we've got 2/3 times 3/2. Oh, I thought I was going to sneeze and then it went away. We've got 2/3 times 3/2 equals 1. So which property do we think is going on there? Oh, and I just realized that I wrote inverse when I meant property. See, I do this all the time. My previous, I was talking about the multiplicative identity and then I wrote inverse. So 2/3 times 3/2 equals 1. Multiplicative inverse. That is correct. Let me actually write the correct word. Inverse. I almost wish that they were different words. They didn't both start with I, because it can be very confusing. So it's multiplying to equal 1. So it's canceling out. And these are reciprocals. So 2/3, the reciprocal is 3/2. So you're just flip-flopping your fractions, which makes it a reciprocal. And they cancel out, they give you 1. So that is the multiplicative inverse. All right, bottom left, 6 times 1/6 equals 1. That is, again, the multiplicative inverse. They are multiplying to cancel out and equal 1, and that is the more traditional form that you'll see a problem like that. And then the last one. So the last one here, I've thrown in another variable, and this one's going to be a little tricky. So you're going to have to kind of do some thinking about this one. Which property do you think we have used here? We've got 1/3 times 3b equals b. This is also the multiplicative inverse, and this is one that you do a lot when you're solving. Make sure I write the correct words. So the multiplicative inverse, we say that they multiply to equal 1. Well, in this case, it doesn't equal 1, but we still canceled the numbers out. We took 1/3 times 3. Those are reciprocals. The reciprocal of 1/3 is 3/1. And 1/3 times 3 equals 1. So it still equaled 1. We just didn't write the 1 there. But we basically used the multiplicative inverse to cancel out the numbers and give us just the variable b. So the things that you're going to see a lot when you're solving, and if you're ever wondering, well, why do we do what we do? You've got this one that we just did. You're going to be doing things like that. You're going to be multiplying by the reciprocal to cancel out whatever number is in front of your variable. The multiplicative identity, where we multiplied by 14 over 14, I mentioned that when you're trying to get a common denominator, you'll be doing things like that. And you're going to be seeing things like this additive inverse, the 6x minus 6x equals 0, where you're going to be canceling out your variables and their numbers to get 0 so that you don't have it there anymore. So those are going to be the three main ways you see these properties being used while you're solving. And so when you're solving, if you're ever wondering, well, why are we allowed to do this? You know, why are we doing this? You want to go back to these properties. The additive inverse, the multiplicative identity, which is used, and then the multiplicative inverse. The additive identity we don't use as much. It does show up, not as much as these other ones. And the multiplicative identity doesn't show up as much as the additive inverse and multiplicative inverse. But those are the three that I've starred are the ones that you're going to be seeing a lot when you're solving. This one specifically, have your problems with fractions. Otherwise, the other two are going to be the ones that you see most often. So, are there any questions? All right, so this is all you really need to know about the properties, and you're not going to be like quizzed on this later. It's just, you know, to understand what's going on. Because a lot of people are saying, well, why do we do this? This is the why. These properties really are explaining the why of things that we do. There are videos, if you haven't seen it already, there are videos in the classroom of some of the other properties that we are covering this week. There are properties just for real numbers, and these are called the properties of real numbers because they're just mostly involving numbers, although I did throw in some with variables. There are also properties for solving, the properties of equality, and those are the ones that are about how we solve equations, and you put those together, and that's sort of, you know, what algebra is. So I'm going to just quickly, when you're in the class, there's this linked videos, and it's also linked in the weekly content. I also have a shortcut in the weekly content, but you can just click. We're in week 2. So this video kind of goes through all of them all at once, but if you want more in-depth, I've got in-depth ones for each of these other properties. So they're longer videos doing just that property. This is a good overview of variables and expressions. And then this goes in more in depth. Then there is some translating going on, converting English sentences to math. So this is a good one to watch. This is more about solving right here. This is an overview of the different properties of equality, and then in depth into the multiplication and division properties right here. And then if you really want to know why we're doing everything we're doing, that's this video right here. So these videos, you don't have to watch every single one. You know, you pick the ones that you think you need for your understanding, but there are lots of videos here. You know, the smaller ones are the overview, and then these larger ones are the most specific ones, so you get a lot more practice. So you can choose the videos that you need more practice on. But I just want to make sure that you guys were aware that these videos are in the classroom. In addition, you've got the videos in Connect Math, but you've also got these extra videos as well. And like I said, they are linked in the weekly content. So I think I put them in the weekly content. Yes. So when you're in the weekly content, there's this icon tells you that it's going to my videos. These are, you know, other videos on YouTube, and then there's videos in the, you don't have to watch every single video. We have a lot of videos, but if, you know, you want to pick the ones that you can understand the best. So if you understand my videos, watch these. If you don't like my videos, you can do these, you know. You kind of pick and choose what works for you. But I just wanted to make sure that you guys know where those are. So that way, if you do need to see extra examples, you know where to find those. And then don't forget that you do need to submit after you do all the work in Connect Math. You take a picture of your grade book and then submit the grade book image here. And then after you take the quiz, whatever you wrote down on paper gets uploaded here. So don't forget about those. Those are really important parts of your grade. Are there any questions? Okay then. Well, that's all I've got for you guys. Thank you for joining me. I really appreciate it, and participating. I really am happy when you guys participate in the chat. I think that's, you know, good fun and makes things more interactive. So thank you for that. And I will see you guys. I'll, you know, interact with you guys in the discussions, and I will see you at the next live for next week. So take care. Bye.